Right, students, welcome to the next lesson, continuing from last lesson where we started on linear. And I did get you guys to complete these questions last time. So hoping you guys did it as we're going to move on. And before you go on and do the next part, which is solving linear equations, you need to make sure you're able to do these questions. Okay, let's get into it. So solving linear equations. So we solve linear equations by operating on both sides of the equation. So that's an important principle to understand here. You're working on both sides of that equation, so the equal sign, until a solution is found. So what you're trying to do is you're doing different processes to find a solution for the unknown variable. All right, so most equations, remember, will have an equal sign, and you're working with all the numbers and letters on both sides. An equation is true for the given values of the pronumerals when the left-hand side equals the right-hand side. So the left-hand side equals the right-hand side. So what this is saying is an equation makes sense when this makes sense with this, or they're exactly the same. X is true when this equation, is true when x equals 5, but it's not true when x does not equal 5. So what we're trying to say here is that we've got to try and figure out what number should this be so that this equals 6. So this is saying 2 times something, take away 4, which is 2 times 5, which equals 10. So if this was 5, 2 times 5 would be 10. 10 minus 4 equals 6. So that makes total sense. Okay, but the idea behind this is that you've got to try and figure out what is this variable, what is the unknown, the x. There's a lot of strategies that you can use when solving equations, such as guess and check, which some of you have probably used before. Backtracking, again, it's just working by hand, but most efficient method is using, so we're looking at this now, the most efficient way is using your inverse operations. Okay, that's the main sort of gist of what you'll be learning today, those inverse operations. So when we talk about inverse operations, we're talking about the opposites of your operator. So an operator is basically, is it positive, is it negative, or is it timesing, or is it dividing, or multiplying and dividing? So is it plus, is it minus, is it multiply, is it divide? And what this little graph here is saying is that the opposite or the inverse of plus is minus. And obviously the opposite of minus is plus. The opposite of multiplication is division. The opposite of division is multiplication. So you need to understand these principles of what's the opposite of adding, it's subtracting. What's the opposite of multiplying, it's dividing, and vice versa. All right, so let's look at some of these examples where we can use inverse operations to solve these equations. So here's an equation right here. X plus 5 equals 15. So the way that I sort of understand this is what you want to do is isolate x, make x by itself. You're trying to make it on its own. So if you want to make x by itself, what are we trying to get rid of here? Well, you want to get rid of that plus 5, okay, because we're trying to make x by itself, right? Therefore, if I get this plus 5, I want to move it to the other side. So this guy needs to move here. Now remember the principle of inverse operations. If this is plus here, if I was to move a number or a constant or whatever it is to the other side of the equal sign, so other side of this, okay, it becomes its opposite or inverse. So if I move plus 5 here, it becomes minus 5 here. And then from there we just solve it. So x equals 15 minus 5, 10. Easy. Okay. Nice and easy. Next one. This is a 3 times y equals 12. Okay, 3 times y multiplied by y. So again, I'm working on that idea that I want to isolate that unknown variable, this y. So if I want to make it by itself, what am I moving? Well, I've got to move that 3. Okay, if this is a multiplied by 3, okay, so because it's 3y, which means 3 times y. If I move that 3, over here, it will become divided by 3. Okay, or alternatively, you could also write it as divided by 3. But we'll keep it to this, I think, because that's how you'll normally see it. And then we just evaluate, what is 12 divided by 3? So y equals 4. And that would make sense, right? Because 3 times 4 will equal 12. All right, so yeah. pretty straightforward, I think. If it still doesn't make sense, keep watching the examples. Just looking at the last one. 6 plus 6b equals 12. Now, when you get a question like this, okay, where you've got a constant, so a constant is a number by itself, and then you've got your term, always start with getting rid of the constant. Remember, the principle is you want to try and make b, or the unknown value, by itself. So that means I have to remove this 6 and this as well, this other 6. All right, so this 6 here, this is a positive 6. Okay, so if I was to move it to the other side, all right, so this is a plus 6. If I bring it here, it becomes minus 6. Okay, so you're left with 6b equals 12 minus 6 equals 6. Okay, now what's left here? Remember, you want to try and isolate that b, make it by itself. Now here you've got a 6 times b. So if I move that multiply by b, on the other side, it will become divided by 6. So multiplied by 6, here it becomes divided by 6. So that means 6 divided by 6 equals 1. And if you try and evaluate that, 6 plus 6 times 1 equals 12. Okay, so hopefully that's made sense. If you come across any of these examples, or these questions, I would highly recommend that you look at these examples again to understand how to solve them. Next one, so let's do examples with fractions. So here we go. Oops. This is a x divided by 4 equals 6. So remember, you want to try and make x by itself. So you're just going to move some numbers to the other side. This is a times or divided by 4. So when I bring it here, it becomes times by 4. That means x equals 6 times 4, 24. Easy. Next one here. All right, when you get a question like this, okay, how do you do it? Well, you want to make sure you start off with a fraction in the bottom if you get a question just like this. Okay, it might be different for other ones, but for now, when there's a fraction in the bottom like this, start off with that fraction. Okay, this is 4x plus 2 divided by 2 equals 9. So what you want to do is this 2 is divided by, and when we bring it here, it becomes multiply. So it's 4x plus 2 equals 18. Okay, let me clean that up a bit. Plus 2 equals 18. All right, now from there, what do we move? Well, this is a plus 2. Okay, so if it's a plus 2 here, I'm treating it as it's coupled with that operator there. So what's the inverse of plus 2? Becomes minus 2. So you get 4x equals 18 minus 2 is 16. Lastly, okay, this is a 4 times x. So when I move this 4 here, remember we're trying to isolate the x, becomes divided by 4. It's times here, becomes divided here. So x equals 16 divided by 4 is 4. So if you're confused about some of the questions, look back at these examples to help you out. And again, remember that a fraction means divide, so the opposite of divide is multiply. So see here, it was divide here, 4 now became multiply. Okay, brackets and variables on both sides. So now you're going to have unknowns on both sides of that equal sign. Okay, so let's look at some of them. First of all, let's look at the brackets. When you get a bracket like this, always expand first. Remember what we learned about expanding in the previous lesson. So if you didn't watch that, please do so you understand how to do this. So for expanding this bracket, you need to multiply with all the numbers on the outside and the inside. So 2 times 5 gives you 10, and there's no variable to multiply with, so it's just 10x. And then 2 times negative 3 equals negative 6. That equals 94. Cool. Now, what's next? Well, remember you're trying to isolate that x. So when you get a question like this, always start off with getting rid of that constant, the number by itself. So this is a minus 6. Here it'll become plus 6. That means 10x is equal to 100, because 94 plus 6 is 100. Next, it's a 10 times x, so it's a multiply here. When I bring it here, it becomes divide by 10. Therefore, x equals 10. Easy. Okay, so instructions are there. Expand the brackets, move 6 to the other side, move 10 to the other side, and yeah. Alright, next one. So now you have unknowns on both sides. Okay, so when you get a question like this, the main aim is to try and group all the similar items together. So 4a and 2a need to be on the same side of that equal sign. Similarly, that -1 and the +8 have to be on the same side of that equal sign. So first things first, it's kind of gone there already, but gather all the like terms by moving 1 and 2a to opposite sides. So I'm going to move -1, that should be -1 here, and 2a to opposite sides. So this -1, if I bring it to this side, will become +1. And this 2a, if I bring it to this side, I'll use another color so it's not too confusing for you guys. This 2a here, when I bring it to the other side, it becomes -2a. Okay, so let me rewrite all this so we can get it. So now what we have here is 4a minus the 2a equals 8 plus 1. Okay, now what we do is put the like terms together. Okay, put them all together. So 4a minus 2a is equal to 2a, and that equals 8 plus 1 equals 9. Okay, and then from there, remember, we're trying to isolate a, make it by itself. That's 2 times a, so if I bring it here, it becomes divided by 2. So the answer is 9 over 2, or it can also be 4.5. Okay, so as a summary of what we just learned, remember what equivalence means. So equivalence just means equal, and inverse means opposite. Okay, and we use these two principles to be able to solve your equations. Okay, let's look at this. What's the similarities between 3x equals -9 and 4x equals -12? Well, we can see that they both have negatives. Okay, and if we try to solve them, this is a multiply by 3, so bring it here, becomes divide by 3, x equals -3. And here as well, get rid of that 4, becomes divided by 4, x equals -3 as well. See how they're both, even though they're different equations, they both equal the same. And lastly, which equation does not belong with the other three? Explain our reasoning. So let's solve this. Okay, x minus 2 equals 4. Get rid of that -2, it becomes +2. That means x is equal to 6. Okay, this is x minus 3 equals 6, so get rid of that -3. Here it becomes +3. Therefore, x equals 9. Here you've got x minus 5 is 1. Bring that here. It becomes +5. X equals 6. And last one, x minus 6 is 0. Here it becomes +6. X equals 6. All right, so the one that doesn't belong is this one. Okay, because obviously x equals 9 here, but everywhere else it equals 6. All right, so do these exercises, please. If you have any questions, please let me know. Thank you.